Hi everyone, this is the answer key for the 5.1 to 5.2 formative assessment. All right, so for questions 1 through 4, the directions say identify the forms of the following questions. In order to do that, we need to remember what the different forms are. So really quickly, I wanted to just write down the different forms that we have. We have slope-intercept form, which is y equals mx plus b. And we remember slope-intercept form, it's always y equals, right? The y is by itself, and we know that there's no parentheses. The right side is completely simplified. So then we also have we also have point slope form. And for point slope form, that's y equals m times x minus x1 plus y1. So both of these are forms that we've been working with pretty much all year now, or at least since Module 2. And then the final form, the one that we just started talking about here in Module 5, is standard form. Standard form is the one that's a little bit different. It's ax plus by equals c. So in standard form, the x and the y are on the same side of the equation, and all of these a, b, and c cannot be fractions. All right, there's no fractions allowed in standard form. Slope-intercept form and point slope form, we can have fractions. So questions 1 through 4 are pretty much just asking which of these forms is this equation in. So if we look at question 1, the x and the y are on the same side of the equation. That must mean that this is in standard form. Question 2 says y equals negative 3 over 2x plus 11. We can see that the y is by itself and there's no parentheses, so this one is slope-intercept form. Question 3 says y equals 1 plus 6 times the quantity of x minus 2. This one, the y is by itself, but there are parentheses. This one must be point slope form. And finally, for question 4, we can see that the x and the y are on the same side of the equation, just like they were in equation 1. So this is standard form. Being able to tell these different forms apart is important because when we ask you to graph them, you need to be able to pull the important information from each one. Okay? Moving on here, question 5 says determine if the given point is a solution to the linear function. So we were given this linear equation, 2x minus 8y equals 14, and we were given this point, 3, negative 1. We want to know if the point 3, negative 1 is a solution. So we're going to take that x value and that y value, and we're going to substitute them into this equation and see if what we get is true. Notice down here that it says you must show your work to support your answer. That means you can't just have a lucky guess here, all right? You have to show us the work that you're thinking through to get to the answer. So the way I always do this is I rewrite my equation without my x and my y, and I just put parentheses. So it's 2x minus 8y equals 14. And so then I'm going to take the x value and plug it in for x, which means I'm going to put a 3 right here. And I'm going to take the y value and plug it in for y, which means I'm going to put a negative 1 right there. And then all I'm going to do is plug it into my calculator and see what happens. So I'm going to plug in exactly what I see here. 2 parentheses negative 3 minus 8 parentheses negative 1, and I get 14, which means I get 14 on this side equals this side was already 14, and I know that that's true. So this is a solution to that linear function. All right, for question number 6, question 6 tells us that we should find the x and y intercepts of the equation. Hopefully you guys can look at this and notice that this is in standard form. And when an equation is in standard form, that's the easiest thing to find actually, is the x and the y intercepts. So I'm going to find the x-intercept first. The way that I find the x-intercept is I know that the y value must be 0. So I always go ahead right away and I make a coordinate point because my answer is going to be a point, and I know that the y value is 0. And now what I'm going to do is I'm going to use the cover up method, and I'm going to cover up the y, which means I'm left with this equation, 2x equals negative 18. So I'm going to go ahead and write that, 2x equals negative 18. Now I can go ahead and solve for x. So I can divide both sides by 2, use my inverse operations, and negative 18 divided by 2 is negative 9. So that's my x value, which is going to go right here. All right, then we do something very similar with our y-intercept, but we know that for a y-intercept, this is when x is equal to 0. So if I make my coordinate point, I know that the first part is going to be 0. So now I'm going to use my cover-up method, which really just means cover up the part with the x. And the equation that I'm left with is negative 3y equals negative 18. Now I can go ahead and just solve for y. Since this is negative 3 times y, I'm going to go ahead and divide both sides by negative 3, and I get that y is equal to positive 6. And there we go. Okay, now we've got these 3 different graphs that we're going to have to do. So we've got the first one says negative 5x plus 3y is equal to negative 15. So hopefully you guys can recognize that that one is in standard form. So I'm going to actually go ahead and write that, standard form. In order to graph an equation that's in standard form, I need to find the x-intercept and the y-intercept. Once I have those 2 points, I can just connect them and draw a straight line. So I'm going to go ahead and actually do the exact same thing that we just did in question 6. So in order to find the x-intercept, I know that my y value is going to be 0, and I'm going to cover up the y in my equation. So I'm left with negative 5x is equal to negative 15. So I'm going to write that right here, negative 5x is equal to negative 15. And now if I divide both sides by negative 5, I get that x is equal to positive 3. So my x-intercept is the point 3, 0. And then in order to find the y-intercept, I know that that is going to be when the x value is 0. So it's going to be 0 something. Well, if 0 is my x value, I'm going to cover up the x, and I'm left with 3y equals negative 15. So now I'm going to go ahead and divide both sides by 3, and I get y is equal to negative 5. So now these are the 2 points that I'm going to put on my graph and then actually make my line. So let's see, 3, 0 is the point right here, and 0, negative 5 is right here. And then all I'm going to do is use a straight edge to draw a line. Sorry, I can't find my ruler right now, so we're just going to use this. But draw a straight line, and remember to draw arrows on either end. And there we go, that one's in standard form. Question 2 then, y equals negative 2x plus 4. This one should look really familiar. This one is slope-intercept form, which means it gives you the slope and the y-intercept. So hopefully you can look at this and you can see that your slope is negative 2. So I'm going to go ahead and write that as negative 2 over 1, because we usually write our slope as a fraction. And then we can see that the b value here is 4, which means our starting point is the y-intercept at 0, 4. And I'm going to go ahead and graph that. So the point 0, 4 is right here. If I have a slope of negative 2 over 1, then that means I need to go down 2 and to the right 1. So I'm going to go down 2 and right 1, down 2 and right 1, And I'm going to fill in as much of my graph as I can so that I can get a really clear picture of what my line looks like. I did all I could going down and to the right, so now I'm going to go up 2 and to the left 1. I only got one more point out of it, but that's okay. And then there we go. There's that line. All right, and last but not least, we have y equals 2 over 3 x plus 4 minus 5. Hopefully you guys can look at this one and you can recognize that this is point slope form. So the slope is the number that's being multiplied in front. That's our 2 over 3. And our starting point, this is what people forget sometimes. Our starting point is the opposite of what's in here, so it's going to be negative 4. And then it's going to be what's outside, which is negative 5. So our starting point here is negative 4, negative 5. So we're going to go ahead and start at that point. Negative 4, negative 5 is right here. And we have a slope of 2 over 3. So that means we're going to go up 2 and to the right 3. Up 2 and to the right 1, 2, 3. And do it again. 1, 2, 1, 2, 3. And I can't do it going that way anymore. Let's see, down 2 and left 1, 2, 3. Yep, I can do that last point right there. And there we go, there's my line. Okay, that was the 5-1 to 5-2 formative. If you have any questions, please make sure that you reach out to either your foundations teacher or your Math 1 teacher and get some help on this stuff, because as we move forward with Module 5, all of these topics, all of these objectives that we covered are going to be really important. Thanks for watching.